Hello, my name is Fernanda Sobral, and today I'm going to solve the quiz number 0 from Physics 2, which is a review from the course of Physics 1. So the problem says, there is a block of mass m which is first at rest, compressing a spring with a spring constant k, a distance x. The block is then released and slides on a frictionless surface until it collides with a block of mass large M that is attached with strings to the ceiling like a pendulum. The larger block has glue on the side, so the two blocks stick together after the collision and swing up to a maximum height h. And well, here we can see a diagram that explains it. So the instruction says, write a problem plan to find the initial spring compression x in terms of the other given variables. You do not need to solve the problem, only write a plan to solve it. Your plan decompose the problem into steps if necessary, describe what physical principles you would use each step, provide reasoning for why these principles are valid. So, whenever we face a problem that has to deal with collisions, what we can do is first divide it in 3 different steps. The first part would be before the collision, the second part during the collision, and the third part after the collision. In this case, I made a drawing that explains the 3 different steps that should be followed to solve the problem. So here we have them. This is the diagram shown in the problem, and this is an extra diagram I made to represent the collision. So for the first step, what we should do is compare what happens when the smaller cube is attached to the spring and what happens right before it collides with the larger cube. So in this case, the smaller cube only has potential energy that comes from the spring that is stored there. So we can write it as, P from potential energy. And this energy should equal the kinetic energy as it is transferred to kinetic energy as the block moves. And it should equal the kinetic energy the block has once it is about to collide with the larger block. So this should be kinetic energy from the smaller cube, right? And this is from the spring. And this should be valid because there is no loss of energy, as the surface is frictionless and we can ignore air resistance in this case. So after this, we can go to the second part, which is the collision. In this case, we can compare the point right before it collides and what happens right after it collides. As this is just for an instant, gravity must not be considered. So we can just compare the momentum, which should be conserved during the collision. So the momentum before the collision should be equal to the momentum after the collision. It's important to remember that this variable relates mass and velocity. So in this case, the momentum only concerns the smaller cube because it is the only one that is moving. It is the only one that has a velocity. But after that, we should take into consideration both. Because they become a system as they are attached together by the glue that is here. So this should be true as well. And then we can go to the third part, which should compare the moment right after they collide, which is the ending point of the second step, with the moment when the blocks reach a maximum height h, which is the moment where they stop just for an instant. So in this case, right when they collide, they have some kinetic energy because they are moving at a certain velocity, and we should consider in this case both blocks. So it's m plus small m. And when they reach a maximum height, they have certain potential energy, which also concerns them both and is related with gravity, as we can remember from Physics 1, because it's a potential energy produced by gravity as it is trying to pull the cubes down, and it is what will eventually make the cubes move back to their initial position, probably. So in this case, we can solve these different equations. This one will give us a velocity that will be useful in this case, and through the variables obtained here, we can reach the value of x, which is present in the potential energy stored in the spring. So this is a plan I would use to solve the problem in this case. And I think it is a very general plan that can be applied for many different problems that involve collisions, as long as we take into consideration all the different forms of energy that take place in each step. So that's all. Thank you.